Welcome to the Organic Chemistry Podcast, Dr. Brian Lloyd's scribblecast of organic chemistry lectures and solutions to homework problems. In this homework problem, you were asked to solve some structures for names of molecules that were given to you. And these molecular names had RS nomenclature in the names. You were asked to draw a three-dimensional structure, and you had to place the longest carbon chain in that structure, vertical, and the highest priority group of that chain at the top, unless otherwise designated. In question A, you were asked to draw a three-dimensional structure of S2-bromo-2-hydroxypropanoic acid. In order to solve this question, the first thing you do is ignore the chirality, S, and just simply draw a structure for 2-bromo-2-hydroxypropanoic acid. Well, propanoic acid is based on a 3-carbon chain propane. So I draw that, 3 carbons. And I might want to space them out a bit more than that. And then oic acid means a carboxylic acid, so I can put that in. 2-hydroxy-2-bromo, so there's a bromo off the second carbon and a hydroxy. And then I put in the appropriate number of hydrogens for the remaining carbons, and when I'm done, I get this molecule. Now I must look at each carbon in this molecule and determine which carbons are chiral, because in order to draw Fischer, the intersection of the two lines is a chirocarbon. As a result, I must find the chirocarbon. The chirocarbons are tetrahedral. They have 4 different groups around them. This carbon has a double bond O, and with only 3 groups is not chiral. The CH3 carbon has 3 identical groups and is not chiral. Only the center carbon has a bromine, a hydroxyl, a methyl, and a carboxylic acid. 4 different groups, so the central carbon is chiral. If I draw a Fischer projection of that chirocarbon, and it says longest carbon chain vertical, I can start by putting the CO2H, which is the highest priority group of the carbon chain at the top, and the methyl at the bottom. And that way I have the longest carbon chain vertical. I also now can put the bromine and the hydroxyl in, and I can put it any way I wish. I can put the OH here, for example, and the bromine on the other side. Now I can prioritize by 4 groups. Prioritization by atomic number. Highest atomic number is highest priority in EZ nomenclature. Bromine is the highest atomic number group. Oxygen's highest atomic number above carbon. And then between the methyl and the CO2H, I have 2 carbons are tied, so I proceed out the chain. Carbon hits an oxygen, carbon hits an H, the oxygen's high atomic number, so the CO2H becomes number 3. And the methyl is number 4. What's interesting here is I now draw my curve from 1 to 2 to 3. I can do this. Why can I do this? I can do this because number 4 is already at the bottom. It's just coincidental. If number 4 was not at the bottom, I would have had to draw a structure or interchange the Fischer to put 4 at the bottom before I draw this curve. Now 1 to 2 to 3 is clockwise here. Because it's clockwise, it is R. I did no interchanges, so this structure is R. I need S. If I wanted R, I'd be done. I could just draw the 3D structure, but because I need S, I got to do 1 interchange. So I'm going to do 1 inter-change. 1 interchange. Okay, I can do that. If I do 1 interchange now, I've got to keep the longest carbon chain vertical. So I leave the CO2H and methyl, and I switch the Br and OH. Because I did 1 interchange, this guy, it's an odd number of interchanges, this molecule is therefore S. S is what I want to draw, so now I'm ready to draw my 3D. In order to draw my 3D, I just translate the Fischer into wedges and dashes. Draw the central carbon, dash, dash. I have methyl here. I have CO2H here. And then I put in my wedges. And I end up with a Br on the left and an OH on the right. And there's the proper 3D molecule and solution to the three-dimensional structure of S2-bromo-2-hydroxypropanoic acid. Let's try the same procedure for the next molecule you were given. In this case, you were asked to draw S2-hydroxy-3-methyl. Phenylbutanal. Okay, and in this question we're asked to place phenyl to the bottom. Well, as before, we ignore the RS nomenclature and just draw this molecule. Butanal consists of 4 carbons, so I space out my 4 carbons. I have a 2-phenyl, a 2-hydroxy, a 3-methyl, and because it's butanal, there must be a double bond OH here. This will have an H and a CH3. Now I look at this molecule and I must determine where the chiral centers are. The aldehyde carbon is not chiral, it only has 3 groups around it. The methyls are not chiral because they have 3 identical hydrogens. What about this carbon right here? Well, it has an H, this big unit off of it, but it has 2 identical methyl groups, so he is not chiral either. Only the carbon with the OH and the phenyl has 4 different groups, so that's my chiral carbon. Now, if I am to draw the longest carbon chain vertical with highest priority at the top, and so there was no confusion, I said put the aromatic ring to the bottom, since there were a lot of carbons on it. You were instructed to do that. I'm going to use CHO for the aldehyde. It's definitely highest by priority by regular nomenclature, and you were to put the phenyl to the bottom. When you are taking a name to a structure, you start by putting the other groups any way you want. So I'm going to put the CH with my 2 CH3s. So that's bracket twice there, and we'll put the OH on the other side. So now I can begin my prioritization. Oxygen is higher atomic number than carbon, so OH is 1. And then if I have a tie, I must proceed out the chain. I have a carbon, a carbon, a carbon. This carbon is an oxygen. The other 2 only have carbons, so the aldehyde group becomes number 2. And now if I compare carbons, here's a carbon. Proceed out the chain, carbon, 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 carbon. Now this carbon has this H, but he has a 3rd carbon. The aromatic ring has the 3rd carbon. So carbon's high atomic number, he gets 3. And the isopropyl gets 4. So I am supposed to do 1 interchange. Okay, I can do that. 1 interchange. if I do one interchange, to put number 4 to the bottom, I will get this guy. OH and aldehyde, CHO is an aldehyde. Don't change, but I put the isopropyl to the bottom. And I move the phenyl over here. And so now I have 1, 2, 3, and 4. Now ignoring number 4, I draw a curve from 1 to 2 to 3. I see this is counterclockwise, so this is S. So the original structure I must have drawn must be R. Is R what we wanted? R is not what we wanted. We must put phenyl to the bottom. So because I want to put the phenyl to the bottom, I do one interchange. I keep the aldehyde on top, keep the phenyl to the bottom, and I switch the isopropyl with the OH. So here we go. Aldehyde on top, phenyl on the bottom, try that again. So my phenyl's on the bottom, and I switch the OH and the isopropyl. Now if I do my 1, 2, 3, because I did one interchange, an odd number of interchanges means you make the enantiomer. This guy must be S. And he's not only S, he is S with the longest carbon chain vertical, the phenyl to the bottom, like I asked for, the highest priority group at the top. It's the proper orientation. So now I'm ready to generate my 3D structure. So I use dashes for the vertical. And wedges for the horizontal groups. And so OH is on the left, CH bracket CH3 bracket twice. And so here is my 3D structure. All right, so there you have it, the solution to both homework problems where you have to draw the 3D structure when given the name. I'm Dr. Brian Lloyd. This is my Scribblecast lecture. Thank you very much.